Welcome all the students in my YouTube channel Physics by TC Chauhan sir. Today we are going to discuss about Airforce special in modern physics. Recent time this is terror of corona and it is better to study at home and it is better way to join our YouTube classes. You must go to the short content as well as long contents with my YouTube channel. You share, you like and subscribe my channel. We are going to discuss about the modern physics, which is having three basic parts. Modern physics is in fact a part in which 3 to 4 different contents are there. We are going to discuss about the questions which are generally asked. Let us discuss. Initially, we start with the electromagnetic waves. It is also a part of modern physics. Electromagnetic waves or EM waves are in fact those waves which travel without requiring any medium, in which electric field and magnetic field are mutually perpendicular and perpendicular to propagation. Electromagnetic waves travel with speed of light, and that is 3 into 10 to the power 8 meter per second. This is speed of light. Another question is, what is nature of electromagnetic waves? Nature of electromagnetic wave is transverse nature. It is always of transverse nature. Then the question, this was question number first, then question number second, then question number third, that is electromagnetic waves have 3 major portion, in which there is electric field, there is magnetic field, and there is direction of propagation. Electric field and magnetic field are mutually perpendicular, like this is electric field, this is direction of propagation, and this is magnetic field which is exactly perpendicular to it. So the question can arise, what is angle between electric and magnetic field? To remember, this is 90 degree. So these are at right angle mutually and right angle to direction of propagation. If electric field is in x direction, magnetic field is in y direction, then propagation will always be in z direction, remember. Then another question is, what does it mean by the Poynting vector? It is major part of electromagnetic waves. Poynting vector is S vector is equal to 1 upon mu naught E vector cross B vector. Whenever electric field and magnetic field are mutually perpendicular and their resultant is taken by E vector cross B vector along with the ratio of mu naught, then it is known as Poynting vector. Poynting vector is in fact energy propagated per unit volume per unit time through a particular medium. This is nothing but Poynting vector. Another question is, what is energy in electromagnetic waves? Energy per unit volume is given by half epsilon naught E square plus B square upon 2 mu naught. This is electric energy, this is magnetic energy. So these are two basic parts. One is electrostatic potential energy, another is magnetostatic potential energy. Now another thing is, what about intensity of electromagnetic wave? This is next question. Intensity of electromagnetic wave is given in terms of energy multiplied with speed of light. This will be half epsilon naught E square into C plus half B square upon mu naught into C. Just we have multiplied with C for energy. So this is basic formula of intensity of electromagnetic waves. Then another question is electromagnetic wave require medium for propagation? It is not essential that electromagnetic wave require medium, not necessary. Then another question is, electromagnetic wave when pass through a medium, then will it get refracted or not? Yes, it will refract. Electromagnetic wave can be visible or invisible. This can be asked in Airforce examination. It is again Airforce special. So electromagnetic waves which can be visible or invisible depending upon the photon or nature of photon or frequency or wavelength of photon. Then another question is, what does it mean by electromagnetic spectrum? So electromagnetic wave has major parts. It can be remembered on the basis of R, M, I, V, U, X, G. These are 7 different waves: radio wave, microwave. R is radio wave, radio waves. M is microwave, microwaves. I for infrared waves. V for visible. U for ultraviolet. X for X-rays. G for gamma rays. So these are electromagnetic waves and electromagnetic spectrum. Remember students, electromagnetic spectrum is arranged on the basis of wavelength and frequency, which is having maximum wavelength. Remember, radio waves always have maximum wavelength. Lambda is maximum and minimum frequency is minimum. Lambda will go on decreasing whenever you are moving from radio wave to gamma wave. It will decrease. Lambda is minimum for gamma rays, wavelength is minimum. But in the case of frequency, it will go on increase and it will be maximum for gamma, that is new maximum. Remember this thing. Now what about application of these spectrum? The question is, what is application of radio wave? In general, it is used for the communication purpose. Then what is use of microwave? It can be used in microwave oven. It can be used in as carrier waves for radio waves. What about infrared waves? This can be another question. Infrared waves are used in photography in night. Infrared waves are very useful in the case of muscular pain relief, etc. What about visible? Visible light is very useful to view objects. What about ultraviolet waves? These are used for identification of fog documents. These are very useful in the case of determination of fingerprints, etc. Identification of fingerprints and the fault currency or fog currency. Then what about X-rays? X-rays are very useful in finding the inner parts of the body where defect takes place or there is position of any bullet or any stone, etc. residing inside body. Then gamma rays. Gamma rays are very useful in the case of sterilization, in the case of treatment of cancer, etc. Now another question. There are several questions based upon that. Another question is, what about the propagation or production of radio waves? Radio waves are basically produced by oscillating circuits or electrical oscillator, LC oscillator, etc. Microwaves are produced with the help of, remember, microwaves are produced by gun diodes, klystron or magnetron. Infrared waves are produced by vibration of molecules. Visible light is produced whenever transition of electron takes place from one energy level to another. Ultraviolet waves are produced with the help of electric arc, or it is produced by source of a particular natural part, that is sun, etc. X-rays are produced whenever fast moving particles or electrons hit a heavy metal target. Gamma rays are produced naturally with the help of radioactive elements. So these are major portion of electromagnetic waves. Another part of modern physics is dual nature and photoelectric effect. The first question is, what is photoelectric effect? Now we shall discuss about photoelectric effect. Whenever light rays are falling on a particular substance of particular frequency, then the emission of electrons takes place from the surface. This phenomena is known as photoelectric effect. Now the first question is, what is basic need? The basic need is the surface should be photosensitive. The second is frequency should be a particular, that is called threshold frequency. Below threshold frequency, photoelectric effect does not take place. There should be particular wavelength, that is critical wavelength. Above critical wavelength, photoelectric effect does not take place at all. Then the next thing is, what about the electron emitted? That electron is known as photoelectron. Now another question is, what does it mean by stopping potential? The potential at which photoelectric current becomes zero. It is always negative potential minus V0. Remember. Next, another question is, what about the location of electron flow? It will always flow from a particular surface, that is called photosensitive surface. It will be located just on the surface, and these will come out as soon as the light fall. There is no gap, or there is no time lag, there is no time difference. This question is again very important. Now what about the dependence? Another question is dependence. What about the dependence of wavelength lambda? It does depend upon wavelength lambda. With the increase of wavelength, there will be change in frequency. Now what is effect of frequency? Whenever we are going to check the effect of frequency, then it is observed that the saturated photoelectric current does not change at all, but the stopping potential changes as soon as we change frequency, nu1, nu2, nu3, then minus V01, minus V02, minus V03. So it will always change. Remember, it is very important. With the change of frequency, saturated current does not change, but stopping potential changes. Then what about effect of intensity of light? With the increase of intensity, whenever we are going to increase intensity, if we draw a graph of potential, then with the increase of intensity, the photoelectric current, that is saturated current, will increase, but stopping potential does not change. This current is going to increase whenever you are increasing intensity. This is about variation. Now what about the cause of this emission or photoelectric effect? It was explained with the help of Einstein. He told that whenever a photon or light fall on a particular surface, then it will emit electron as its energy is divided in two parts. One part is used up in giving a particular kinetic energy, half mvm square, and other part is used in doing work, that is called work function W0 or phi naught. Then its energy, that is energy of photon, will be h nu is equal to half mvm square plus h nu naught, or you can say W naught, or you can say phi naught. This is also known as Einstein photoelectric equation. Another question is, which conservation is followed by Einstein photoelectric equation? So it is conservation of energy. Einstein photoelectric equation always follow conservation of energy. Then another question is, what is practical application of photoelectric effect? It is practically used in a photo cell. This is a photo cell in which two rods are there, in which one is acting as cathode, other is acting as anode. When light rays fall on a particular negative electrode, then electrons are emitted which are captured by positive electrode and will flow through the circuit in which a micro emitter is attached. So this is all about the photo cell or photoelectric cell. Here, whenever light rays fall on cathode, there will be electron emission due to photoelectric effect, and flow of electron will cause photoelectric current, that is known as photocurrent. Now the question arises, what will be changed with applied potential? With the increase of potential, the photoelectric current initially increases and then become saturated. At a particular negative potential, photoelectric current becomes zero. That is known as stopping potential. Then what about the cause of photoelectric effect? The basic cause of photoelectric effect is energy transition, energy transfer. The energy of photon is transferred to a particular electron. That's why classical wave theory fails. This is very important question. Why classical wave theory fails? Classical wave theory fails as the energy of photon is completely transferred to a particular electron. This is about photoelectric effect. Now another part of modern physics is dual nature or matter wave. It was discovered by scientist de Broglie. He told that whenever a fast moving particle or electron or any particle which is moving, then with its speed motion it will behave like a wave. He told that a fast moving particle always behave like a wave, and that wave is known as matter wave. Matter wave have particular wavelength. That wavelength is supposed to be lambda, and that lambda will be h upon p. The question is lambda proportional 1 upon p. What does it mean by p? P is linear momentum. P is equal to m into v. This is very important question. Now another question is, what about de Broglie's wavelength in terms of energy? It will be h upon under root 2 m ek. Ek is nothing but kinetic energy. Now what about wavelength in terms of temperature? This is a very important question. So h upon under root 2 m. In place of ek there will be kT, that is in terms of temperature. T is absolute temperature. Another question is, what about wavelength in terms of temperature for a gas? Then for gas, lambda is equal to h upon under root 3 m kT. It is also important. What about T? T is nothing but absolute temperature. Now if a charged particle is moving, then what about de Broglie wavelength? That will be lambda is equal to h upon under root 2 m q into v. Q is charge and v is potential. Now few direct questions based on numericals are there. You have to learn those datas. For electron, lambda electron is 12.27 upon root v angstrom. Just put the value of v, get the result. Lambda proton will be 0.286 upon root v angstrom. Remember, lambda deuteron will be 0.202 upon root v angstrom. Remember, lambda alpha will be 0.1012 upon root v angstrom. It is also very important. This also you have to learn. In general, we use a concept of determination of wavelength with the help of de Broglie's hypothesis, and that de Broglie hypothesis is given for a particle only. It means a particle when behaving like wave, then fast moving waves should also behave like particle. This crisscross theory is also true. Then we gave the concept of matter waves. Matter waves were discovered by de Broglie but verified by an experiment Davison German. This recently asked in Airforce as well as Navy examination that who did experiment along with Davison. The German did the experiment along with Davison. Now another question is, what about the concept of crystal or grating? In which case a crystal behave like grating? Remember students, whenever distance between atoms is more than distance between lattice plane, that is d should be greater than d, then it is known as grating, or this crystal is known as grating. Now on this basis a formula of diffraction is given. Whenever diffracted electron beam is going through a crystal, then there will be a particular angle of diffraction. Diffracted beam is scattered in several manner. Then a scientist which is called Bragg, B-R-A-Z-Z, he gave an equation, and this equation is N lambda is equal to capital D sine theta, or n lambda is equal to 2D sine phi. This is very important. This is also called Bragg's equation. Lambda is wavelength, D is distance between atoms, small d is distance between lattice planes, and theta is angle of diffraction, and phi is angle between incident beam and lattice plane, diffracted beam and lattice plane. Now let us discuss about atom and atomic physics. What about atom? Atom is smallest building particle of matter, but this theory failed. The question arises, who gave the first theory of atomic structure? Then you should say the first theory of atomic structure was given by J.J. Thomson. Thomson gave first atomic model, and that atomic model is given on the basis of small spherical structure in which positive charge is uniformly distributed and negative charges exist at particular places. So, but this theory failed because negative charge will move around a particular positive charge which is lying exactly at center. So this theory failed. Then another question is, by which experiment size of nucleus was discovered, or nucleus was discovered? So nucleus was discovered by Rutherford alpha particle scattering experiment. Another question is, what is size of gold foil used in Rutherford? That is 10 to the power minus 8 centimeter. This is order of size of gold foil. Then another question is, what about the location of alpha particle which retrace and how much far it is away from center? So it is almost 10 to the power minus 15 meter away, or 1 Fermi away, and this is size of nucleus. Another question is, who gave the first proper atomic model? And that is Bohr. Your answer should be Bohr gave first atomic model. According to Bohr, there are basic 3 postulates. First postulate is mv square upon r is equal to 1 upon 4 pi epsilon naught ze square upon r square. Another question is, on what base this postulate was given? So remember, this postulate was given on the basis of circular motion and electrostatic. It is very important. Then what about the second postulate? Second postulate is mvr is equal to nh upon 2 pi. Now the question arises, on what basis this postulate was given? Another question is, on the basis of Planck's quantum theory, this postulate was given. Planck's quantum theory or quantum analysis. Now another question is, what is Bohr's third postulate? Bohr's third postulate is En is equal to En2 minus En1. On what base it was given? It was given on the base of Maxwell electromagnetic wave theory. So this is also very, very important. Now another question is, what are basic drawbacks of Bohr's atomic theory? Basic drawback is, here nucleus was supposed to be stationary, no proper reason was given. Here the circular orbits were taken, but in fact orbits are elliptical, which was proved by Sommerfeld. Another is, it was failed to explain the proper reason of quantization of orbitals. He has taken Maxwell electromagnetic wave theory and Planck's quantum theory together, which is impossible. He was failed to explain spectrum. He was failed to explain the effects which are Stark effect and Zeeman effect. So these are few drawbacks. Another question is, what is major drawback of Rutherford's atomic theory? The major drawback of Rutherford atomic theory was that stability of atom. He told that electron revolving will continuously lose energy, but in fact it is not so. It will not lose continuously energy. It will lose or gain when it will jump from higher energy state to lower energy state. So this theory was failed. Then what about the lines of different spectrums? There are basically 5 series of line spectrums. We are taking few levels, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, n is equal to 6. When transition of electrons takes place from second, third to the upper one to first energy level, then it will be Lyman series. It is called Lyman series. In the case of Lyman series, the wavelength will be given by 1 upon lambda is equal to r into 1 upon n1 square minus 1 upon n2 square. Just put n1 is equal to 1 and n2 is equal to sequence wise. When transition of electrons takes place from third, fourth, fifth to second, then it is known as Bohr series. It is n1, here we will take 2 and n2 will be sequence wise. Then transition takes place in third from the upper level, then it will be Paschen series. Then here we will take n1 is equal to 3. Then after transition takes place in fourth level, then you should take n1 is equal to 4, and at last when it takes place in fifth, it will be Pfund series. So there are 5 basic series. First is Lyman, second is Bohr, third is Paschen, fourth is Brackett, and fifth is Pfund series. The wavelength in these series is very, very important. Now what about the numerical question? Here radius of orbit is asked. Radius of orbit will be Rn is equal to 0.529 n square upon z angstrom. This is very, very important. It can be asked in terms of ratios. What about the ratio of this? This is very important question. R1 is to R2 is to R3 is equal to 1 square is to 2 square is to 3 square. That is 1 is to 4 is to 9. It can be in this term. Then after, velocity can be asked. What about the velocity? Velocity will be Vn is equal to 2.19 into 10 to the power 6 z upon n meter per second. Whenever ratio is asked in this term, then V1 is to V2 is to V3 will be 1 upon 1 is to 1 upon 2 is to 1 upon 3, etc. Then after, energy is asked, which is very important. Energy will be En is equal to minus 13.6 upon n square electron volt. This is very, very important. Here the ratios will be E1 is to E2 is to E3 will be 1 upon 1 is to 1 upon 4 is to 1 upon 9, etc. Remember, E1 for first energy level minus 13.6 electron volt. E2, that will be minus 3.4 electron volt. You have to learn this. It is directly asked. Now, this was E2, this is E3. The energy in third energy level will be 1.51 electron volt. Then you have to learn directly. E4 will be minus 0.85 electron volt, and then E5 will be minus 0.54 electron volt. So these particular parts are very important. These are directly asked in Airforce examination. Then what about effect of atomic number? In this case, then energy in this case in terms of atomic number will be given by En is equal to minus 13.6 Z square upon n square electron volt. Then what about the wavelength, frequency and wave number? This is very important. The wavelength, whenever electron transit from one energy level to another, 1 upon lambda is equal to R 1 upon n1 square minus 1 upon n2 square. Frequency will be nu is equal to C upon lambda. That will be CR 1 upon n1 square minus 1 upon n2 square. And then there will be wave number nu bar, that is 1 upon lambda, and that is R 1 upon n1 square minus 1 upon n2 square. R is nothing but Rydberg's constant. Remember, Rydberg's constant is 1.097 into 10 to the power 7 meter inverse. That's all for today. You share, like and subscribe our YouTube channel and take its maximum benefit. Thank you.